In August 1665, deadly bubonic plague came to the village of Eyam in Derbyshire. The terrible story is told on the stained glass windows in the church. The first person to die was George Vickers, the tailor. He'd ordered some cloth from London to make a new dress for the rector's wife, and something in the cloth brought the disease. The plague spread quickly through the village. 6 people died in September, 23 in October. The parish register shows the full horror. There were about 300 people in the village. Within 18 months, more than 250 died. Imagine how awful it must have been when they didn't know who would be next. Brothers, sisters, parents. In 1 week, Elizabeth Hancock lost her husband and 6 children. She buried them in the field by the house. No one knew what caused the plague. All they could do was try and avoid spreading it by keeping apart, by isolation. The whole village cut itself off from the world outside. No one went out, no one came in. Food was left at the boundary stone, and to pay for it, they left money in a pool of vinegar. Do you think the people of Eyam were right to isolate themselves? And if you'd lived in the next village, would you have dared to take them food and collect their money? Today, we can avoid catching many dreadful diseases by having jabs or injections. What do you think you get in a jab? How do jabs help to prevent disease? Jabs were invented because of a killer disease called smallpox. The story begins in a village in Gloucestershire. Dr. Jenner was an expert on cuckoos. He was also a good scientist because he asked the right questions. What he really wanted was to conquer the deadly smallpox. Cows sometimes caught cowpox, and milkmaids often caught cowpox from the cows. Cowpox didn't do the milkmaids much harm. What interested Jenner was that they never seemed to catch the deadly smallpox. Thousands used to die from smallpox. Why not milkmaids? Could it be that cowpox got in the way? Could catching cowpox stop them catching smallpox? To test his theory, he needed someone young who hadn't had either cowpox or smallpox. He chose James Phipps, aged 8 3/4. He told the lad he thought he could stop him from ever catching smallpox and that it wouldn't hurt much. Then he took some pus from Sarah's cowpox and rubbed it into 2 small scratches on the boy's arm. Cowpox was called vaccinia, so Jenner called his invention vaccination. In a few days, James was poorly with cowpox, but he soon got better. 6 weeks later, Jenner took pus from a smallpox victim and deliberately tried to give James Phipps the deadly disease. There was no cure for smallpox. But James didn't get smallpox. He lived to a ripe old age, And now smallpox has been wiped out thanks to Edward Jenner and his vaccination. So how do you think jabs help to prevent disease? And what causes disease in the first place? Some things are too small to see clearly with the naked eye. Like this flea, for instance. Scientists use microscopes as aids to help their vision. A microscope is a kind of scientific eye. Microscopes can magnify things as much as 1,000 times, but some things are so small you can't see them even with a microscope. This is an ordinary pin magnified about 10 times. Let's find out what we can see if we magnify it more and more. 300 times. It doesn't look quite so smooth and sharp now. 1,500 times magnification. There's a cluster of stuff near the point. It's like a camp, a whole army camping on the point of the pin. These are microbeasts, the microbeasts that cause disease. Microbeasts are so small that one or two can't hurt you, but when there are millions of them, they can make you very ill. Microbeasts don't grow like us. Instead, each one divides into two, and each of those into two more. If they have enough food, they can multiply very quickly. Suppose you started with one, and it divided into two every 20 minutes. How many would you have after an hour? And after a day? You can find microbeasts almost everywhere, but they're so small you can't see them unless you let them multiply. These scientists are collecting samples from various different surfaces and spreading them on agar plates. Agar plates provide food for the microbeasts to multiply. Different surfaces may have different microbeasts, so it's important to label the dishes. The dishes are sealed up with sellotape and left in a warm place for the microbeasts to multiply. After a day incubating in a warm place, the various microbeasts have grown different colonies on the agar plates. This speeded up film shows how the colonies grow. What makes bread go mouldy? It's the tiny fungus growing on it. Microbeasts are everywhere, even on people. These are the microbeasts that cause boils. But they aren't all bad. You have millions of microbeasts living on your body, and many of them are useful. Inside your gut, you have microbeasts that help you digest your food. They turn some of the food into a gas called methane, so if you fart, it's because of the microbeasts in your gut. Cows need microbeasts to help them digest grass. What do the microbeasts help the cow to make from the grass? Dairies use microbeasts to help turn milk into cheese. And into yogurt. Do you like eating live microbeasts? What else is made by microbeasts? Beer is made with yeast, which is another microbeast. When it's thoroughly mixed into the liquid, the yeast is left to grow in big warm tanks where it can multiply by feeding on the malt. The fermentation makes the beer alcoholic. Within 24 hours, the malt is turning into beer. Microbeasts can be used in all sorts of ways. At this dairy, they put them to work on the sewage. In an underground tank, microbeasts feed on the sewage and make methane gas, which is used as fuel for this generator. The electricity runs the lights and the milking machines, so the cows almost milk themselves. Remember, there are microbeasts everywhere. Although some are useful, other microbeasts cause disease. Why is it important to wash your hands after you go to the toilet and before you eat? Doctors recognised the dangers in the 1860s. Joseph Lister was a surgeon in Scotland. Almost half his patients died from infection of their wounds, so he invented an antiseptic spray to kill the microbeasts. By using it during operations, he was able to save 5 patients out of 6. What precautions do they take today? During the Crimean War, 70,000 Allied soldiers died in battle. But nearly 3 times as many died of disease. 40% of those who went to hospital died. This woman, Florence Nightingale, insisted on proper hygiene, on keeping things clean, and she cut the death rate to 2%. How do you think microbeasts spread from person to person? Can you guess how one person who's ill might infect everyone else in the room? In spite of all we know, microbeasts are still dangerous today. One weekend in July 1980, 9 children from this school were taken ill with vomiting and diarrhea. Can it be the school dinner? An environmental health officer calls to collect samples of the food. In the public health laboratory, scientists have to try and find out if there are any dangerous microbeasts on the food. This is a stomacher. The stomacher churns up the mixture of food and water into a sludge or broth. Any microbeasts will now be floating about in the liquid. The broth is spread onto agar plates and left to incubate for a day so that colonies of microbeasts will have time to grow. The job of the public health lab scientists is to try and find the causes of the disease by tracking down the dangerous microbeasts. When the colonies have grown, they're identified and counted. Could these have been enough to make the children ill? Vital detective work for a scientific eye. Lots of colonies, but nothing dangerous, so school dinner couldn't have caused the illness.
Environmental health? Oh, yes. Just for a moment, please.
Meanwhile, more reports of illness have come in. Every detail is written down for the environmental health officer. What do you think might have caused the illness? How would you try and find out?
Hello, Frank. I think we've got a problem. How many inspectors have you got in?
The first stage of the scientific method is to make observations and gather information. For environmental health officers, this means asking questions. What sort of questions would you ask to try and track down the cause of the disease?
So can you tell me what you had for breakfast on that day,
Yes.
please?
Cereal, bacon and egg,
Yeah.
toast and marmalade.
Toast and marmalade.
The second stage of the scientific method is to analyse the information, to look for patterns. By this time, more than 100 people have become ill. It doesn't seem likely that so many people can have eaten the same food, but could they have drunk the same milk? Samples are checked at the public health laboratory, but no dangerous microbeasts grow on the agar plates. So it can't have been the milk. But by the next day, 3,000 people have been ill. Can you guess what could have infected so many?
Yeah, but this is the area that's affected, taking in the south of Wetherby, running down to Collingham, as far as Bramham.
All the illnesses are in one small area, and all the people affected are supplied by one water main. What would you do if you suspected the water? To check their theory, they'd test the water. Samples are sucked through special filters designed to trap the microbeasts. The filters are then incubated with special food to allow them to multiply. Sure enough, the water is contaminated. It seems that dangerous microbeasts from this stream have got into the water main. So, if you were in charge, what precautions would you advise people in the area to take? How would you cut off the source of the infection? And what else can we do to cut down the spread of disease?